This is, oh, hello. This is video E, and I'm going to use every fiber of my being and focus and concentrate. See if I can make this one fairly short. This is actually, was supposed to be part of the last video, but these videos have been longer than I intended so far. They're almost half an hour, and I apologize for that. I'm not in the rhythm yet. When I get in the rhythm, I'll cut myself off sooner and have shorter videos. So here's a continuation of the discussion about assignment statements. We need to look at arithmetic operators, A-R-I-T-H-M-E-T-I-C, operators, O-P-E-R-A-T-O-R-S. And over here, I'll put the meaning, in other words, what it does. Some of these are ridiculously obvious, insulting your intelligence again, and others look like strange beasts that would have no purpose for existing. But let's take a look at them anyway. The plus sign means add. Of course it does. Or it means positive, depending on how it's used. If it's a binary operator, if it's between two things, between two numbers or between a variable and a number or whatever, then it means add. If it's a unary operator, if it's a plus sign all by itself in front of something, then it means positive. See how to play that game? Same thing with a minus sign. Minus means subtract, or, you guessed it, negative. Prognosis, negative. Subtract if it's between two things, negative if it's in front of something by itself. Now, the ones that are a little less absolutely obvious, perhaps, the star or the asterisk means multiply. The slash, I think that's forward slash. I don't know. I get it mixed up. Can't tell left from right. That means divide. And of course, the percent sign means modulus. What the what? We'll look at an example of that. Modulus, let's see, short and sweet. It's the remainder if you do integer division. Divide, by default, when we're using integers, will be integer divide. It throws away any fractional part of the answer. This kind of catches it more or less. I don't even know why I try to describe it. Let me do the examples and then you'll see. I'll show you. Here we go. Example, I'm not going to start with modulus. I'm going to start with this. Double. Uh-oh, they could have decimal points. Average 1, average 2, average 3, abbreviated. AVG1, comma, AVG2, comma, AVG3. And yes, we're headed toward a trace, but I'll do the trace in a different color over there so that it doesn't look like it's part of my source code. See how I'm using these big words? Source code, this is what I might type in. And let's calculate average 1. AVG1 equals 3 plus 5 plus 9 divided by 3. Oh, of course it does. What could be simpler? Average 2. AVG2 equals, and I'm going to put these in parentheses for whatever difference that makes. 3 plus 5 plus 9, close parentheses, divided by 3. And I did it. I accidentally lied again. I'm not going to write the third one up there until we trace this far and see what happens. And see if this is, see if this makes any difference. Hint, yes it does. AVG1, which originally has, 0? No! Not a safe assumption. It originally has garbage. AVG2, also garbage, or as the French might call it, garbage. And average 3, also garbage. Now, see, now I wish I hadn't written the second one first. Now you see what's wrong with the first one first, don't you? 3 plus 5 plus 9 divided by 3. The rules, the precedence rules, the order of operations are, it will go through and do any multiplication or divide before it does any addition or subtraction. So it's going to start with this part, 9 divided by 3, which is 3. 3 plus 3 plus 5, 5, 6, 7, 8, 9, 10, 11. 11! So it's not actually finding the average of 3 and 5 and 9 because it's dividing too soon. It divides 3 into 9, gets 3. 3 plus 5 plus 3 is 11, so average 1 is 11. Since it's double, I like to put 0.0 as a visual indicator over here in my trace that could have had a fractional part of the answer. Just like, you know what? Now we're going to fix it. Look how we fixed it. This tells the computer, actually it's instructing the compiler, translate this into machine language that'll do the addition first and then divide by 3. That should fix everything. 9 plus 5 is 14, 15, 16, 17. 17 divided by 3, scratch work time. 17 divided by 3. Let me see, did I write this down? 17 divided by 3. 3 won't go into 1, long division here. 3 goes into 17 5 times. 3 times 5 is 15. 2 left over. Average 2, I could keep going, couldn't I? It's going to be a repeating fraction. I don't have to. This is an integer. If I don't put decimal points after these things, if I just say 3 plus 5 plus 9, then I get whatever I said. I got 17. That's 17 as an integer. When I divide an integer by another integer, I get an integer. So until it actually looks on the left-hand side over here and says, you know what? That's going into a double variable. I need to store that as a number with a decimal point. It doesn't look at this entire division problem. It only looks at the whole number part and stores that as 5.0. Yikes! That's not the average of 3 plus 5 plus 9 either. It looks like we can't fix it. Oh, but wait. Average 3. Here comes fix to the rescue. I can do this. Look what I can do. AVG3 equals, parentheses again, watch this. 3.0 plus 5.0 plus 9.0. Divided by 3, and I don't even have to put 0.0. Actually, it's ever so slightly disingenuous for me to put 0.0 there because I'm dividing by how many numbers there are, and there are exactly 3 numbers, not a fractional number of numbers. So now it is going to divide all this, and according to my precise calculations, it's going to store that as 5.6xxx, and it'll round off the last one to a 7. So I'll suggest that average 3 was probably the result we were looking for with each one of those 3. This is the only one where we expressed it correctly. Now, how can I be certain that I will get the decimal point in the answer even though there's not a decimal point here? Well, let me ramp it up just a little bit. If there is a double value, a number with a decimal point, anywhere in this calculation, then it does the calculation as a calculation of double values. In other words, just 3 all by itself without the 0.0. If I added plain 3 to 5.0, that is stored internally as a temporary result as 8.0. It's already been converted to double. So if there is a decimal point appearing in any of these numbers in any part of that expression, then it will be calculated as a double value. It's called casting up. Casting up. If there are no double values to be found, then the result is an integer, and it's not even converted to a double value until it's set to the variable on the left-hand side. See how to play this game? Yeah, there might be some questions about that in a Zoom session, but I'm out of board space, and we still haven't solved the mystery of the modulus. Ooh, I even came up with a title for it. The Mystery of the Modulus. I'm going to do this one by example. Example 2. Integer, here we come, integers, possible round-off errors, leftovers, camel cased, capital O, int, leftovers, answer, semicolon, answer. What is the answer? ANSWER. equals, and I'm going to use parentheses to make sure things are done in the right order, 9 plus 5, close parentheses, divided by 5. And I'll get my partial trace going over here. Trace. Leftovers. I know people who don't eat leftovers. They view it as garbage. See what I did there? Leftovers is garbage. Answer. Well, until further notice, answer is also garbage. See if we can do the math. 9 plus 5. 9 plus 5 is 14. Scratch work area over here. This is not an official part of the trace. 14. 9 plus 5, 14. Divided by 5. 5 goes into 14, not in a whole number of times, so I've got a problem here. Goes into 14 twice. 2 times 5 is 10. Subtract and get 4. That's all integers over here. Integer sum, integer divide, 14 divided by 5 is 2. The answer is 2. Well, to that problem it is. It might not be the answer we wanted. It's not the whole answer. Watch this. Leftovers. The remainder gets its day in the sun. Leftovers equals exactly the same thing. 9 plus 5. Except instead of the divide, I'm going to put the percent sign, the modulus. Percent 5. Guess what? This 2, that was the answer to the divide. The slash gave me that. This, the throwaway part, the remainder, I got that from the modulus. I'm not sure that these symbols, this was a slash. That is 14 divided by 5. This is 14 modulus 5. So nothing is wasted. We even hung on to the leftovers with that second statement, and leftovers is 4. See what happened there? That's what the modulus operator is. Now, that solved the mystery of what the hey it does. It doesn't solve the mystery of how could that possibly be useful. It will sneak into examples that we will be looking at as the semester rolls on, where nothing else will do the same thing modulus does as elegantly. It will really smooth things out for us. And I promise this is going to be a shorter video. You know what? We're not going to go through all the rest of this stuff. Not right now. I'm going to say I'll see you online and chop this off immediately. Here we go. See you online.